questions on calculus using JAMB's UTME Mathematics 2015. Question 1. Find the y dx if y equals cos x. Now, the fact that we need to know is that if y is equal to sine a function of x, then the y dx will be equal to f prime of x cos f of x. What does that mean? F of x is a function, so we'll differentiate this f of x and then we'll change this sign to cos. So we'll use f prime of x to multiply cos f of x. Okay, we'll differentiate this f of x. When we differentiate f of x as function of x, you get f prime of x. So we use that to multiply cos f of x. And similarly, if y is cos function of x, that's f of x, then the y dx will be equal to minus f prime of x sine f of x. We change this, we differentiate this f of x, then we change this cos to minus sine. So we have minus f prime of x sine f of x. And if y is equal to tan f of x, our the y dx will be f prime of x sec square f of x. Okay, I hope that is clear. So if y is cos x according to the question, the y dx will be minus sine x. So the correct answer is option A. Question 2. If y equals x sine x, find dy dx. So if we want to differentiate this kind of function, we need to use what we call product rule. And product rule states that if y equals u of x times v of x, times is product. If y equals u of x times v of x, then the y dx will be u times dv dx plus v times du dx. Right, so our u is equal to x. That's the first one here in the answer question. Our u is x and our v is sine x. Our u is x in x sine x, and our v is equal to sine x. Remember the formula states that dy dx will be u dv dx, that's u times dv dx plus v times du dx. Now we're going to differentiate our x. Since our u is x, so the u dx will be 1. Our v is sine x, so dv dx will be cos x. Now we have u x, v sine x, du dx 1, and dv dx cos x. So put these values into the equations, into the formula for each parameter, for each symbol. Now instead of writing u dv dx plus v du dx, write u is x times cos x. Cos x is standing for dv dx, then plus v. Our v is sine x, right, times du dx, which is 1. So we have x cos x plus sine x. So that is option D, which is sine x plus x cos x. That is our dy dx for the function. Option B. Okay. We need to remember that if y is u of x times v of x, then dy dx will be u dv dx plus v du dx. That is product rule. But in the case that we have u of x divided by v of x, then that is quotient rule. Quotient. So our dy dx will be v du dx minus u dv dx all over v squared. That is if we are using, if we have fractions a fractional function. So that is what we're going to use to find our dy dx. Again, let me further explain something here. Here I said that y is equal, if y is equal to sine x. Now what you have to understand here is that if y is equal to sine function of x, okay, we said our dy dx will be equal to f prime, so f prime of x. Now this f prime of x here simply means that we differentiated. Look at the two things that we did. We differentiate f of x here, this f of x, and we got f prime of x. Then we change this sign to cos. We change this sign f of x to cos f of x. That's all. So for instance now, if I have sine 4x now, the value of dy dx will equal to, look at this function of x, which is 4x here. We differentiate it and we get 4. Then we change sign 4x to cos 4x. That's the derivative for this function. And then if we are having y equals cos 4x squared, okay, our dy dx, so we are having 4x squared here. This is 4x squared. These are y is equal to cos 4x squared. Our dy dx will be equal to, remember when you are differentiating cos, you need to have minus. So we first differentiate this 4x squared, and that gives us 2 times 4, that's 8. So we have 8x, that's not 8x. Then we'll now change this cos 4x squared to sine 4x squared. Is that okay? 4x squared. Right, so that is how to differentiate this function. That's the meaning of minus f prime of x sine f of x. When differentiating, you can see it was cos f of x that we have as a function. So we differentiated it and we have minus f prime of x sine f of x. So that's differentiation of cos function. If we are having tan function now, let's say we have if y is equal to tan, let's say 9x now. Now our dy dx will be equal to, look at this tan, and this 9x here, we differentiate it, we get this 9, then sec squared. Now instead of writing tan 9x, we write sec squared 9x. So that is how to differentiate trig functions of this kind. Okay, I hope this is clear enough. Thank you for taking your time to watch the video. I really appreciate the fact that you are watching my video for this time around, maybe the first time, or you choose to watch again. I hope you enjoyed the lesson. Please like the video and subscribe to my channel. Thanks for watching. Thanks.